Hello everyone, it's a great honor to be here at, probably stand here. It's a very great honor to be here at PyCon UK this year. Today I'm going to be talking about serverless programming and how you can use Python in your serverless programming. And this is something that I've been using serverless for a while with Node.js, but last year I came across AWS Chalice. When I started using it, I was very surprised with how easy it was to just get started and deploying stuff, and it has a lot of functionality. So I thought it'd be very interesting to share this with all of you here today. Quick intro, as introduced, my name is Mashhood, and I am coming all the way from Pakistan, Karachi. I work as, so my official title is the CTO, but it's a small startup, so I lead the engineering team at Sastateket, which is a travel-based startup based in Pakistan. It's like Expedia for the local country. Besides my professional work, I do a lot of community work. So all the logos you see there are different communities that I'm helping, I'm part of. I'm going to point out two of them. Python Karachi is our local Python community over there, which I lead. And this year, I'm the lead organizer for PyCon Pakistan. That's happening in a month's time on 12th of October. So if any of you are interested, please let me know after the talk. So we're going to start off by just getting a feeler of what is serverless and what is the problem it's trying to solve. So just to get an idea from the audience, how many of you guys are using serverless right now? Right, a few people. How many people of you have understand what serverless is? Right, a few more, yeah. But for most people, serverless is kind of something that's very specialized. It's a very specialized tool, and we'll see why when we go dive into it. But it can be used as a general purpose tool as well, and that's what Chalice is trying to make it essentially. So we all build applications, and we build awesome applications, and one of the most important part of applications is deploying them. Normally when we're building applications, assuming, let's say we're making a monolith, we'll take it, we'll put it on the server, and then we'll deploy it. So one thing that we have to think about is this huge, the failure in deployment, right? So that's a single huge failure that can happen to our application. And once in production, then you obviously have to think about scaling as well. And that's where you can think of either vertically scaling it, either adding bigger and bigger machines, or horizontally scaling it, adding more machines and then load balancer in front to ensure that it can balance the load across all machines. So the point we're trying to make here is that these are non-trivial things. And as a developer, I don't really want to spend too much time thinking about how do I deploy, how do I make sure my server does not go down, how does it scale up and down, how does it take on the spikes, how do I make it more efficient so that it's not costing me more when there's no load on the server, and things like that. So there have been different strategies around there, and one of them is microservices architecture. And so assuming we start off with a monolith, you can decompose the monolith into smaller services, and then you can individually deploy and scale those services. So it's easier in the sense that, yes, you're not breaking your whole application at the same time, but it does add a little bit of overhead. With tools like Kubernetes, you can effectively scale it up and get it up and running pretty quickly, but at the end of the day, you're still managing servers. And that essentially requires effort, resources, and expertise. And this is what we're trying to avoid. So there was this other concept that came in, this is about almost 10, 15 years ago, functions as a service. And the idea was very straightforward. You wanted to take your services that you've decomposed for microservices and break them down further into just functions. Now, since you've broken them down to such a small level, each function can be deployed independently, it can be scaled independently, and now since it's a lot easier to run that function, your cloud vendor can take over the infrastructure for you. And this is optional, obviously. We're talking about AWS Lambda today, so obviously cloud vendor will take over, but you can also deploy that yourself if you feel the need for that. So in 2014, AWS Lambda was the first major cloud provider service that came in and made the serverless paradigm popular. And they marketed Lambda as a microservice without servers. So what does that really mean? That essentially means that they've abstracted the server out from the terminology. As a developer, you do not get to interact with any servers. You don't get to SSH into any servers. There are no IPs involved, nothing, right? So how does it work? So there are three main components for Lambda. And the first component is a Lambda function. Now, the interesting part is, the Lambda function is obviously the function of code you wrote, but it's not just that. It involves any binaries that you used when executing that function. It involves any libraries you used when running that function. Everything needs to be packaged into a single zip file and uploaded to AWS Lambda. So that is a little bit non-trivial when it comes to writing that function. The second thing we want to talk about is the event source. So I talked about efficiency. And the cool thing about functions as a service is that your function is not running all the time. It only runs when it's needed to be run. That means when it's not running, it's somewhere on the disk somewhere, and then when it's needed, it's brought up into the memory, and then it's executed. So in order to run that, you need an event source that will trigger the function. And in our case, for most of us, it is an HTTP server. It's an HTTP request that hits the Lambda function, and then that triggers it. But it could be something else as well, like, let's say, a cron job, or adding a task in a queue, or uploading a file to S3, for example. We'll have a look at those further down in the talk. The last thing over here is AWS Lambda service. And this is where your function will run. This is the compute service for AWS Lambda. And this is essentially what is meant to be a black box for the developers. This is how it runs there, when it runs there, if it's a cold start or not, we don't really care. We all know is that when we trigger the function, it will run, and it will run on AWS Lambda service. So very quickly, these are some of the use cases for Lambda. Real-time file processing, stream processing, ETL, IoT backends, and web. So you can see that the use case is pretty wide. It's not just for very specific type of applications, but there are restrictions on this that we'll talk about in a bit as well. So coming on to the topic at hand today, and that is AWS Chalice. Where does Chalice fit into this? So Chalice is essentially a Python framework that is a set of utilities and a CLI to help you deploy your code base on AWS Lambda. You see, the problem was that when AWS Lambda came out, people couldn't really figure out how do you write code for Lambda. Like, most of us are sitting here right now. Can I just write a Flask app and deploy it on Lambda? Where does the web server go? It's not making any sense. It's a very different paradigm of thinking. So in order to help you get started, they essentially created this framework. And with this, you don't have to go through any of the documentation for Lambda. You simply just go through the docs for Chalice, which is literally just one page, and you're up and running. So Chalice, like I mentioned, has a set of utilities. So here's a list of a lot of the things that Chalice can do. But instead of going through them, let's try building something with Chalice and see how it can help us build some awesome services. So today we're going to build, and this is a live session here, just we're going to do it over slides, a dashboard of who's currently in the office. This is just a silly idea I had a while back. I wanted to check who's right now in the office. And so we are going to do this by tracking the Wi-Fi network. You can put a Raspberry Pi on your Wi-Fi routers, and that will effectively check whenever a MAC address connects to the router or disconnects and send that information to the server. And on the server, we will maintain the correlation between MAC addresses and users. And obviously, this is all opt-in. This is all meant to be like for fun. It's nothing really serious. The dashboard looks something like this. As you can see, I can see that there are 3 people in the office. One is online, and he has been online since 3 hours. There was somebody offline since yesterday. That means they haven't come in today. And there's someone who's offline just 15 minutes ago, right? So just to give you an idea of how it would work. So we need these APIs. We need an endpoint to get all the users, create users, update users, delete users, and obviously something on the Raspberry Pi that will send data to our service. So how do you set up a web application on AWS Lambda? This is the recommendation from AWS themselves. Your front end will go onto Amazon S3. This has got nothing to do with Lambda right now. We'll simply upload the files there, and they will be served from there to the users, to the client side. The client side will run the HTML and JavaScript, which will trigger an API gateway request. So whenever I hit an endpoint, it first goes to API gateway, and then that triggers the Amazon AWS Lambda function. Once the function runs, it will go and fetch the information from an Amazon DynamoDB, which I'm going to be using in this case, right? And that Amazon DynamoDB is a hosted MongoDB on Amazon. It's pretty straightforward. So this is going to be set up separately from the rest of the application. So getting started locally, what do we need to set up? We need Python, obviously. Chalice supports 3 versions for Python, 2.7, 3.6, and 3.7. And these are the environments that you get on AWS Lambda. So you can't run Python 3.5 because it doesn't exist on Lambda, right? You can't go install it over there as well. You're kind of limited to that. You configure your virtual ENV and enable it, and then you install the Chalice library. The second thing that you need to do in order to set up locally is configure your AWS authentication, because Chalice effectively will create all of these resources for you in Amazon, in your console, so it needs to have access to your account. Now we can get started. So we have this Chalice CLI, and in this we have a command called new project. We'll call this project Big Brother, and for those of you who were having privacy concerns before, you now know where this project is going. And this essentially creates 2 files for us, just 2 files. And the one file is requirements.txt, which is essentially an empty file. We'll use it later. The second file is this setup file, which has just 6 lines of code. And what's happening here? The first line is importing Chalice from the library. We're initializing the application. And then we have this very nice decorator, which defines what kind of route we're targeting. So we're essentially targeting the root endpoint for our application. So whenever somebody hits on the root endpoint of our API, then I want to return a JSON of hello world. But interestingly, this is Python code. So what I'm actually returning over here is not JSON, it's a Python dictionary. So Chalice automatically converts this into JSON for us, puts in the right headers, and returns it as a response. So these are all these small utilities that are just built in, and they let you use, let you make the API in Python like it should be, and you don't have to worry about all these little things when you're building the application. So let's change this up. We need our first endpoint for fetching users. I've made some changes. First of all, I've imported a DB module from Chalice lib. Now, Chalice lib is a folder which you can create to put in any additional modules that you have written yourself. So this folder then gets packaged into your deployment, into your build, and then gets shipped to AWS Lambda. This name is specific, Chalice lib, so if you name it anything else, it won't work, so just be careful of that. The next thing I've changed is obviously the route/users will be where we get our users. And then in the users function, I'm getting a database reference and then calling list all users on that. So the database reference that we have is essentially returning a global variable, DB. And if it's not initialized, it initializes that. The reason we do this is because when you run a container on AWS Lambda, the first time it runs, it's created, you get connected to the database. But if you trigger it right after, let's say after a few milliseconds, then AWS Lambda will reuse that container. So if I write my code like this, then it will reuse that database connection as well. So it's going to be a lot faster, right? So this is a small trick to reuse a database connection if your container is still warm. Next up is our database service, and in this case I'm using Boto3. Boto3 is a very famous Python SDK for AWS, and now the interesting thing over here is that I mentioned that I have to package the library when I'm deploying to AWS Lambda, and Chalice manages everything for me at this point, right? So all I have to do is import it, put it in my requirements.txt, and then run the command at the end, and it will package this library automatically and ship it out for me without any additional work. In the implementation itself, it's pretty straightforward. I have a reference to my table, and then in the list all users function, I simply scan the table, get all of the results, and return them. Very simple. Once I've completed my first endpoint, I want to test it locally. And again, this is another challenging thing. If I'm talking about serverless, how do I go about testing these things, right? So Chalice again has a nice command which lets you run this locally, and it also supports automatic reload on save, which is very useful. So I'll just run Chalice local, and then I'll hit the endpoint to see if my code is running properly. The next up is we need to add users, right? So we need to create a post method on our users route, which I've done here. So I've just added the method parameter, and that's going to create a separate route for me in API Gateway, and link this second function to that link. In the function, I'm using the current request.json body. Now again, it's a small thing, but Chalice is helping me. It's taking the JSON that's coming into for the request, converting that into a Python dictionary, and then I can just pass on the Python dictionary with the double stirring into my function so that it passes everything, all the keys as parameters. So it looks very nice. Same way, in my update function, I have a euro parameter because I obviously want to update one user, and I get that username in my function parameter, and then I pass it on to the update user function. One thing missing from the previous one was validations. So what happens if you want to validate your requests? So in this particular case, inside my add user function in the database, I have added a validation to check if the MAC address is of the right format. And if it's not, it's going to throw an exception for invalid MAC error, which will in return a bad request error, right? So it's giving you enough customizability to control your responses and the type of responses you want to send back as well. So for the final endpoint, where we want to send data from the Raspberry Pi to our server, we want to do something different, because this is an endpoint that will be continuously streaming data from the Raspberry Pi to the server, right? Because people are going to be connecting and disconnecting all day. So for that, I would like to use WebSockets. And yes, WebSockets are supported by AWS Lambda. The way it works is that WebSockets themselves are deployed on API Gateway. That's where the WebSocket server lives. And then whenever there's a message on the API Gateway, it triggers the function likewise. And this is all the configuration that we have to do for our WebSocket function. We need to set a session, because we need a session in our, so this is going to be managed by Boto 3. And then we'll turn on the experimental feature flags, because this is very new. And finally, all we have to do is use the decorator on WebSocket message and take the event. The event.body has the data that I've sent, and I put it into my database. Very simple. Like this, WebSocket also has on connect and on disconnect, and I can reply back. Obviously, I have to maintain the user data to which users are being connected. But that's not, again, not very hard. If you're doing a WebSocket implementation, that's going to be pretty standard for everyone. Finally, we have all our endpoints ready, so let's deploy this to production. So there's a single command that's Chalice deploy, and that does everything for you. It will create your builds, it will create all the resources needed, the Lambda functions, the API Gateway functions, the REST APIs, IE and roles and whatnot, and it will output the endpoint at the end. That is the REST API or the WebSocket API that you're looking for. And this takes less than 30 seconds, so it's super fast and it's super amazing to use. So that was easy. Just to review a few other things that Chalice can do. And this is an example where I'm uploading files to S3. And whenever I upload a file to S3, I'm listening on a particular bucket, an S3 bucket that I have. And I'm listening to a particular event, in this case, object created, but it could be object deleted or updated or anything else. Or it could listen to all the events as well. And that triggers this Lambda function. And in this particular case, I take the file from S3, I download it onto my Lambda function, I split it up into lines, and then I pass it on to my database to be added in there. So this is like ETL, where I'm taking files, parsing them, and then uploading them to my database. Likewise, cron jobs is another very popular thing that we're doing all the time. Again, super simple. We can just use the app.schedule, and you can set in the rate over there. So it could be minutes, days, seconds, or whatever you like. In this particular case, in this example, we're just fetching the report data from the database, and we're sending an email out to everyone who would like to see that. This was one of my favorite features about AWS Chalice. So when you start using serverless, initially you're always using it for experimentation. Maybe like a Hello World API, or maybe something very small that you want to do. And chances are that you might want to delete it right after, once you've done playing. So before, because you're configuring so many things in so many different places, it was really hard to keep track and then go back and delete everything. And this one command simply goes and deletes everything that was created for you. So this is super useful, and this just encourages you to go out and experiment using this framework. Just to wrap things up, AWS Lambda is not a golden egg, as mentioned. It has some issues. The most controversial issue is the function cold starts. So because your code is not running all the time, it takes a few milliseconds. On average, it's about 500 milliseconds to start up in the first time you hit it, right? So this is something that can be a concern to certain applications. There are ways to mitigate around this. You can find them online. Something to be concerned about. API Gateway has an idle timeout of 30 seconds. That's fixed. You can't increase that. So if you're trying to do a long call or something like that, that's not going to work with Lambda. With API Gateway as well, you can use something else instead of that. Lambda execution limits. I've mentioned this. We have limits in terms of memory. You can have maximum 3 GB as a memory on your function. You can have 15 minutes of maximum execution time. So the task has to be small. You can't run it for hours. So you have all these execution limits. There are more of them. You can find them on the documentation side. So these are something to review when you're trying to build your own application on AWS Lambda. And Lambda is obviously more expensive to run as a compute service. So this is funny because it depends on what you're trying to do. If your service gets hits like 100 times a day, then it's obviously very cheap. You get like a very good quota of like 1 million hit points or something for free initially. And then the extended rate is also pretty low. So if your frequency of usage is very, very low, then this could actually be free for you. But if the load's really high, if you compare it to your EC2 compute pricing, it's going to be more expensive, obviously. The final thing I've mentioned as well is the package size limitation, which is at 250 MB, which is actually pretty low. So if you're using any big library that has a binary of, let's say, 500 MB, you can't obviously push that onto AWS Lambda. That was it from my side. I hope you enjoyed the talk. Thank you all so much.
We have time for a question? Yeah. The mic is down, so you have to repeat the question from here.
Sure.
Yeah, well, okay.
Pros and cons against Zappa.
Okay, sorry.
Have you used Zappa before?
Zappa, no, I haven't.
Okay, okay.
Is it backend as a service?
So it's a community-driven Python deployment tool for serverless. So it uses Lambda.
Cool.
But you can use, or you would use Flask or Django or something like that in there instead.
Yes.
I played around with Chalice a year or two ago, and I struggled, but I'm sure it's a lot better now. I was just wondering, like, I guess you perhaps don't have this perspective on this, but like, have you found limitations of the Chalice web server in comparison to Django or Flask or anything like that?
Can you repeat the question on the mic?
Yeah, sure. So we're essentially looking at if the Chalice web server has limitation when you compare it to Flask or Django, right? That's
yeah.
One place where Lambda outperforms Flask or Django is the fact that you're running on serverless, right? And the biggest advantage of serverless is that you can scale up pretty fast. So in Flask or Django, you're usually deploying that over on an EC2 machine. in case you're deploying, I haven't tried deploying that on serverless, so I'm not sure how it would behave. But I would imagine Chalice would be faster because it has a lot less. So it's very much like Flask. It's very bare bones, so it's not doing much, and that kind of gives you the edge in terms of performance. Django, I guess, would be a little bit slower, but I haven't tried that out yet.
One last at the back.
So you showed Chalice deploy and delete, which were great. If we're using Terraform to sort of deploy everything else, is there a way that we can still use Terraform and Chalice rather than have to use that a little bit and Terraform builds?
That's actually interesting. Again, something I haven't tried. So for this particular thing, we've always used the Chalice deploy. So our core infrastructure in my startup is also on ECS. So that's where the main application runs, and then we have some support utilities running on Chalice. So we have separate deployment pipelines for both. We're not using Terraform for deployment of this, and that's just because it's a lot simpler. You don't have to maintain this and stuff. So, but theoretically, I think it should be possible. I'm not seeing any issues because it's essentially doing the same thing as Terraform.
Okay, we're wrapping up. Let's thank Mashhood again.